Hello everyone, you might be thinking, why is this video? And well, that can actually drawing Mike Manzer can help me to learn how science can be understood easily. Well, uh, so you might be wondering right now, what if science was easier to understand if we could see it instead and just read about it? Well, today we'll explore how drawing can help us to learn real science. You don't need to be an artist, just curious, and you don't need to be a very uh, like a person with a lot of motivation, very motivated person to understand this, and you will be uh, wondering right now, how many questions, and one of them could be the when do we start? Well, we start right now, and the video consists in 3 times. Well, to start, textbooks versus drawing. The second one, how we can learn to the example of Mike Manser lifting weights, and that's all. And we will use drawings to understand how the body grows muscles, creates energy, and even astronauts train in space. So let's begin by drawing a simple muscle. And first draw arm, then draw bicep, the muscle between your elbow and shoulder. And you may wondering right now what we are doing right now, how I can learn science, more things about it with just drawing muscles. Well, it's easy to explain this because when you lift a weight, your muscles create tiny tears, and this is called micro trauma. But don't worry, that your body repairs it, doing your body stronger and heavier, and endurance it and makes it grow. So I'm drawing an arm to show you your muscles, but you can use a drawing of Google about your muscles, the system muscle, and the label is the bone, muscle belly, tendon, and joint. This is what we are going to see right now as we end. And to the drawing, you can send this to show very more well muscle fiber tearing when you're and when you're lifting weights, and the rows tear recovery draw, and this process called hypertrophy, and the signs of muscle growth. Mike Manser used this principle to strengthen more but not longer, and the sources of this are Khan Academy, muscle structure, Confend, strength, cut, rest, 2010. So if you have any questions about the sources of information, they are there. Okay, the chapter number 2, we can start about energy in your muscles. Well, now the next step to learn more about science of how muscles get energy, we need to draw a big circle, and that's your muscle cell. And you may be wondering, what is a cell? Well, a cell is like, you may know the atom. The atom is the smallest particle possible of something, because if you if you see very closely the atom, you may see only electrons, protons, and neutrons. So but there are for every atom in general of anything. So if you a piece of air, like you with a you look at it very closely, well, with your eyes not may know, but with a gadget that is specifically to that, to like see atoms and some stuff like that, you may see that the smallest particle of something is the atom, because if you go inside the atom, there are only electrons and protons, and that's all we can see, as I think as now. Because neutrons, protons, and electrons is for anything, for any atom, and we are composed by like many particles, a lot of cells of something, because for example our blood is composed by cells, and inside those cells they are chemics that are like composed by our ADN, and the ADN is composed by atoms, and the atoms is the smallest particle possible that we can difference between others, because if we go inside the atoms, they are all the same. They are all neutrons and protons. So and you may think why we use the muscle cell and no muscle atoms, because it doesn't exist muscle atoms. The muscle is composed by 70% water and 30% proteins and others chemics. So that's why I'm using right now a muscle cell, because there is a lot of different types of cells. The cells that are in your blood, in your skin, in your brain, in your bones, in your muscle. So that's why I'm using the cell. Inside the cell, we draw three mitochondria that are them here, and add oxygen and glucose for ATP. And you may be question yourself, what is ATP? Well, that's it. Well, it is. This is called cellular respiration, and it happens inside the mitochondria, the power plant of your cell, for being like engaged. So glucose plus oxygen equals ATP. Muscle contracts, and no ATP, no movement. So because of that, McMahons are trained with short intense sessions, because ATP burns out quickly, like he said. Then he rests a lot, so ATP could recharge, and the sources those abilities, the like thesis, are kinecharmy, mitochondria, NASA, muscle energy loss in zero gravity. Next chapter of today is science of recovery, and you may think, what the hell could this like help to me to know more about science and the small particulars that are in war and chemics and explosions or things of like that stuff. Well, we need to know our body first before knowing all the things that are outside of us. So that's why I'm starting with this, and a very helpful example of something that happens in our body can be when we train and our muscles grow due that train in sessions. So the muscles grow actually when you rest, not when you live, because when you live it only grow a bit because of the glucose and blood that is there in your muscle flowing because of your training. But actually it grows like is the name grow when you actually rest, because when you rest you don't know anything, so why we doesn't grow. so to understand this, I'm drawing a graph. X-axis is the time, y-axis is muscle strength, the curve is drop workout, rise is recovery, and peak is grow, and fall is overtraining. What can we conclude to this is the supercompensation curve. If you train too soon, you crash. Train too late, you miss your chance. So train after the peak for the best results. And the zone 1 is fatigue, the zone 2 recovery, the zone 3 peak, and the zone 4 were trained. And the source of this is Satsiorski and Kramer. That is valid right now still. And the last chapter 4 is about hormones and sleep science. Now let's draw the inside of your brain, the pituitary gland. This tiny gland produces growth hormone while you sleep. So let's draw it to show you how this thing called pituitary gland forms inside your brain. Well, if you don't know, a pituitary gland is a tiny gland inside your brain that produces hormones when you are growing, when you become a teenager, after you were a child, and your testosterone grows and your levels of testosterone grows. Well, that small part of your brain produce that, and this connects with your nuts, so you can build more testosterone. So that's why you don't have to fap yourself. And the brain there is the drawing to make you understand more easily. And the growth hormone and testosterone help repair and build muscle, but cortisol, the stress hormone, can do the opposite. And you may be wondering right now, what are you saying to me that if I have too too much stress, can I be skinnier than last time? Well, the answer to the yes is absolutely yes, because it has been like measured in the past. Like Mike Menzer said, most of your growth happens during deep sleep, not at the gym. Well, you also need to be in the gym. You can sleep a lot and eat a lot and don't do anything else. You also need to train, but the train has to be quickly but very intensive and progressive in weights. But you can only use 1 or 2 sets per exercise per exercise if you want. Well, the last chapter is about the bench press physiology, and let's analyze a real movement, the bench press. Mike Menzer used this to target the chest, but the science goes deeper than that. Well, I'm drawing along a bench, the person with a barbell, arrows directions of force, and the label are the pectorals, triceps, and deltoids, and each rep includes eccentric phase. And you may be wondering what the hell is an eccentric phase. Well, it's when your muscles are stretched, and this happens in the lower part, and the concentric phase is when you are lifting the weight in the, for example, in the bench press, when the muscle contract. So this builds tension, which leads to fiber damage, and that fiber damage correctly implemented with force improvement, for obviously for natural people, I don't think that you may want to deal with steroids. It can due to a lot of growth if you have the good technique to do this exercise due to this muscle tension. And for finish this class, the muscle fiber types are only two. Type 1, endurance, where you're running a lot in the same pace. You have muscle endurance, type number 1, and type number 2 is strength. I mean the force that can do that muscle, or articulation can be also called like that. And the source is ACSM guidelines for resistance training, and the chapter number 6 for, and this is that in space, for example, in space, astronauts can lose up to 20% of muscle mass in 2 weeks due to no gravity. And that's why astronauts need to train a lot, because, like I'm drawing along right now, astronaut flooding resistance machine, or ISS, and arrows showing load of muscles, and the NASA use elastic resistance and even electrical stimulation to maintain muscle health. And the explain is that no gravity equals no resistance, and no resistance equals to no signal to grow. And if you don't grow your muscles are gonna be, or at least if you don't work out, your muscles aren't going to grow. Your muscles are going to be like on development more and more according to the time, and artificial tools are needed to replace gravity. And the source of this obviously is the same NASA, muscle loss prevention for the astronauts. Well, that's all. And to conclude, let's review what we just learned about science. Well, micro tiers. If you want to grow your muscles, you need to have a very good program that can make micro tiers to your muscles, and using strength progression ATP equals energy, like I said. Sleep for plus your hormones grow, and sleep is like it's a cheat code of life, and recovery is almost the same to sleep, is supercompensation, and the brain pituitary is going to help your hormones if you are less stressed, and the NASA equals resistance in space. So the final challenge of today is now draw your thigh muscle map, combine all these pieces you learned today in one big diagram. You can send me to my email if you want to write it and to read it and outline your drawings to my email. And to finish the class, join the Kahoot quiz that is in the link below description, and submit to the Google form in the description as well to earn a digital certification. And that's all. And optional resources to do is that also in the description is a Google Drive with more classes like this, and PDF handouts, recovery curve, ATP cycles, drawing guidelines, and that's all. I hope you liked this class, and well, I hope you like it.